The position values of an axis are always in relation to the axis coordinate system. The homing procedure defines where the 0 point of the coordinate system is. Select the command for homing the axis. The command block is inserted in the editor. Double-click the command to parameterize it. Select the required axis. Then select the required homing type. Then specify the home position coordinates by entering the value 0. Confirm your configuration. The command to home the axis has been inserted and parameterized. Now determine the target position and the starting position for traversing the axis. The program should traverse the axis with a velocity of 200 mm per second to position 2000 mm and then return to the starting position 0. Insert a command to position an axis. Each current block is highlighted in blue. Double-click this block. Select the axis to be traversed. Specify the target position. Then specify the velocity. Confirm your entries. Now insert a further block to position the axis at the starting position. The axis should return to position 0. You have now specified the positions for traversing the axis. You just have to cancel the axis enable now and stop the axis motion correctly. The enable must be cancelled again. Finally, the start variable is reset and the ready variable set. Select the command for cancelling the axis enable. Double-click the block you have just created. Select the required axis in the dialog that opens. Confirm your configuration. Then insert a variable assignment block to complete the program and parameterize the block accordingly. Save and compile the project. Congratulations! You have created your own program with the Motion Control Chart programming language. If you are using an in-feed with drive-click interface, a program extension is required to control the in-feed. You still require an additional block for the control of the in-feed, which you also use in an until loop to switch on the in-feed. Therefore, insert the system function call command block. This resets the operating parameters of the in-feed to their initial values. In addition, this also acknowledges alarm messages that prevent enabling of the in-feed. Parameterize this block by taking the line module control function call from the command library into the system function. Then, define an instance for the system function call and set the variables to the appropriate values. Notice, you can do this with the autocomplete function. Note that we are using an in-feed of the active line module type in this sample project. Insert another until loop and parameterize the condition. The block that you insert in the loop will switch the in-feed on. The loop repeats the switching command until the infeed is ready for operation. Insert the block that you have just created into the loop. Finally, adapt the system function call inserted in the loop. You have now extended the previously created program with a program sequence which switches the infeed on. You still require 2 empty motion control chart programs for your application, which you will connect later to the Simotion Scout TIA execution system. The execution system that you configure in a later section requires 2 further motion control chart programs. These programs must be created, as otherwise the CPU goes into the stop operating state when a technology fault or a peripheral fault occurs. In real applications, you can specify the reactions of your machine to a fault in these programs. You create these programs with a new unit fault. The first program that you create is Technology Fault. This program remains empty. The second program is Peripheral Fault. This program also does not require any further programming. When you have created the programs, save them and compile the changes. All motion control chart programs that you require for your application have been created. In the next step, we will show you how to work with another graphical programming language, the Ladder Logic and Function Block Diagram Programming Language. You create an LAD FBD unit for the sample project as follows. Open the Programs folder below the Simotion device in the Project Navigator and double-click the appropriate entry. Then, enter the desired name for the unit. Then go to the Compiler tab and activate the Permit Program Status checkbox for diagnostic purposes. Confirm your entries. The unit is created in the Project Navigator. The declaration table of the unit opens in the working area, which is not used in the sample project. Next, create a program in this unit. You have already created a motion control chart program in a unit. Proceed in the same way with this program. Open the unit that you have just created. Then, click the entry to create a program. Also, enter a program name here. Leave the setting in the Creation Type field. Click OK. The project is created and opened in the working area. You can now start with the programming. Write a program for the sample project in which the global device variables are read cyclically and the I/O variables set accordingly. Open the created program and click the icon for creating a network. A block with a coil is inserted in the editor. Also insert an NO contact in front of the coil. The change is displayed immediately in the editor. Transfer the appropriate variables for NO contact and coil from the symbol browser or from the address list by dragging and dropping. Or use the autocomplete function. Then, insert a further network with an NO contact and coil. Also assign the appropriate variables here. You have now created all programs which you can assign to the tasks of the execution system. In this section, you get to know the Simotion execution system. you assign the sample project programs to the tasks of the execution system. You thus transfer the programs from the Simotion Scout TIA engineering system to the Simotion runtime system. The programs control the system as soon as the operating state of the Simotion device is switched to the run state. The Simotion execution system comprises execution levels which define the chronological order of the tasks. A level can contain several tasks. In turn, a task can contain several programs. By assigning the created programs to the tasks, you can, for example, define the priority, the time frame, or the order in which the programs are to be executed. In the following, you assign the sample project programs to the tasks of the execution system. Double-click Execution System in the Project Navigator below the Simotion device. Then select Motion Task 1 in the opened window. The Execution System window opens. Assign the MCC program which you have created to control the setup axis to the selected task. The program is displayed in Programs Used and in the tree of the execution system. It is therefore assigned to Motion Task 1. Activate the Activation After Startup Task checkbox. This executes the program immediately after the Simotion device is started. Now assign the other programs that you have already created to the desired tasks. Close the Simotion Scout TIA execution system. For the changes to take effect, you still have to compile the configuration and download the project in online mode to the Simotion device. Configure the execution system as follows. In the next steps, we will show you how to start and then stop the Simotion CPU. In this section, we will show you how to switch the CPU to the run operating state. You can see on the hardware that the axis rotates twice for approximately 8 seconds. After execution of the program, you switch the CPU back to the stop operating state. You can switch the operating state in Simotion Scout TIA and on the Simotion device. However, the setting of the operating state on the Simotion device has priority. Simotion Scout TIA can only switch a Simotion device to run mode when the mode selector switch on the device is set to 0, i.e. run. To switch a Simotion CPU to one of the operating states in Simotion Scout TIA, use the Control Operating State dialog. Simotion executes the user program and the associated system services in the run operating state. The Simotion device is switched on and powered up in the stop operating state, but does not execute any programs. You can start the axis control of the sample project on the Simotion device as follows. Open the Control Operating State dialog box. In the next step, switch the Simotion CPU to the run operating state. The program that you have created is started immediately. You can see on the hardware that the axis rotates twice for approximately 8 seconds. After executing the program, it stops again. The Simotion device remains in the run operating state. Then, switch the Simotion device to the stop operating state. If you want to traverse the axis again, you must acknowledge the pending alarms. You have now started and stopped the execution of the program for controlling the configured axis. In the next and last module of this tutorial, you can conveniently monitor the program execution on the screen of your programming device. In this section, you monitor the program-controlled axis motion. First, you monitor the execution of the program that you have created in one of the previous modules. Then, you monitor the variable values in the symbol browser and record the curve of the axis motion with the trace. Creation of the trace time diagram concludes this tutorial. Simotion Scout TIA provides various functions for monitoring and recording the program execution or the variable values. Use the Monitor function to monitor the program execution in the sample project. With this function, you can track the execution of the command blocks in a chart. The currently executed command block is highlighted in yellow in the chart. The symbol browser is available to monitor variables. You can read out status values or assign control values here, for example. You can also combine different variables of several devices, objects or programs in a so-called watch table to monitor them jointly and to control them if applicable. Furthermore, Simotion Scout TIA provides the trace tool to record and evaluate parameters or also system and program variables of a CPU. Use the Monitor function to monitor the program execution in the sample project. Open the motion control chart to control the created axis. Then, switch the monitoring function on and start the program control. The program is run through once. The currently executed command block is highlighted in yellow. Then, switch the Simotion device to the Stop operating state in the Control operating state dialog. In the next step, we will show you how to monitor variable values in the symbol browser. For the sample project, you monitor the actual axis position during the program run. Select the already created axis in the Project Navigator in the Axes folder. The system variables and configuration data are displayed in the symbol browser. If the symbol browser is not visible, activate it via the menu bar in the Detail view. Open the variable that saves the values of the actual axis position. To find the variable quicker, use the Filter function of the symbol browser. Then, start the program control via the Control operating state dialog. The program is run through once, whereby the changing values of the actual axis position are displayed in the symbol browser. Since the Simotion device remains in the Run operating state after running through the program, switch it back to the Stop operating state. Different variables, for example of several devices, can also be combined into a table to be monitored. To take a variable into a watch table, you must first create a watch table. To do this, double-click the appropriate entry in the Project Navigator and confirm your configuration. Then, select the desired variable in the symbol browser and add it to the created watch table. The selected variable is displayed in the table. In this way, you can add further variables to the watch table and monitor them. You can record and save the desired values with the Trace tool, which we will introduce in the next section. For the sample program, record the actual axis position over time with the trace and display it in a diagram. To do this, you must first parameterize the trace. Select the SIMOTION device in the network view and click the appropriate icon in the toolbar to open the trace. Enter the recording duration in the Trace tab. Then call the dialog for the signal selection. Select the Positioning State entry in the tree. Select the system variable Actual Position in the Variable table. To assign the system variable to channel 1, click 1. Repeat your channel assignment for the next variable and confirm your entries. You can also drag and drop the variables from the symbol browser or the watch table to the signal field of the trace dialog. If you close the trace parameterization now, it will be deleted. You should therefore save the trace parameterization in the trace dialog via Transfer to Catalog. You have now parameterized the trace and can start with the recording. You record with the trace as follows. First, download the parameterization of the trace to the target system. Then open the time diagram in the device trace. Start the recording of the trace. Then switch the SIMOTION device immediately to the Run operating state. The program is started. The actual axis position is recorded and displayed in the time diagram. After the recording duration expires, the signal curve of the actual position is displayed. If the recorded curve is only partially displayed, select the Auto Scaling command in the shortcut menu of the time diagram. After executing the program, switch the SIMOTION device to the Stop operating state. Congratulations! You have successfully completed the configuration of the sample project and are now in the position to be able to perform the typical configuration steps, such as creating an axis or configuring a drive on your own. With this getting started, you have got to know the typical configuration steps in SIMOTION Scout TIA. You have worked not only with the TIA portal, but also with SIMOTION Scout TIA. You have created a project and then a SIMOTION device in the TIA portal. You have completed the configuration in SIMOTION Scout TIA with regard to the motion control parameterization and programming, as well as the automatic configuration and connection of the drive. You are now in the position to create an axis and control it with the Axis Control Panel or a simple program. Further information on this topic can be found on the Internet and also in the SIMOTION Scout TIA help. Finally, we would like to thank you for your attention and wish you lots of fun with the SIMOTION Scout TIA engineering system.